Welcome back to geometry. Our last big section is about circles and how lines interact with those circles. So here we have some circles and they happen to have some right triangles connected to them in specific ways. See if you can find the radius. So the first problem is going to be Pythagorean theorem, and you should end up getting r is 5. In the second problem, I could use Pythagorean theorem. It's going to be r squared plus r squared equals 18 squared. If I simplify that and keep exact answers, it would be 9 square root 2, and 9 square root 2 is approximately 12.73. The third one is a very tricky one to set up, and we'll actually do more of these later, but we have to recognize that the hypotenuse is r plus 4, and sometimes you might do a little guessing and checking with this one. The radius in this particular one happens to be 6, and 6, 8, and 10 is a Pythagorean triple. But we will do more of these problems later on. So we're going to identify some different parts of lines that are related to these circles, and then solve some problems involving tangents. Tangents are a funny little thing, and they are very related to a circle. These are all different definitions that you're going to need to get used to. The two that you already have are the radius, which is from the center to the edge of the circle at any point. The diameter goes through the center of the circle. It is actually considered a very unique chord. A chord is a segment whose endpoints are starts and ends on the circle, and the diameter is a unique one of the chords. Then we have a secant. So a secant is a line that crosses the circle and it keeps going in both directions, so it is a line. So a chord is a part of a secant. And then we have the tangent. And when we say something is tangent to a circle or to a curve, it touches the circle at only one point. Well, the only way that we can do that is if the circle curves down to it and then curves away from it. So instead of crossing the circle, it just touches the circle. And that place that it touches is called the point of tangency. We can call a tangent can be a ray, a segment, or a line. Doesn't matter which one. We're just going to name them slightly different. So based on learning these terms, we want to be able to identify what different terms these things are. AC. AC, well, it ends at the center of the circle, so we would call that a radius. Radii being a singular. DE, now it's a little hard to tell on this, but this is a ray, and DE still touches the circle at only one point, so it is a tangent. AB goes through the center. It has a start and a stopping point, so that is a diameter. AC, it's important to note that it is a line, and that eliminates the idea of it being a chord, so this is going to be a secant. Whenever we are referring to a circle, we often will refer to it with a little mini circle symbol and the letter for the center, because the center is the most important part of the circle. So this is circle C, and all of these things are related to circle C. Have a couple more terms. Now it's fairly common for two circles that are on a plane to have 2 points that they intersect. The choice is they have 2 points of intersection, 1 point of intersection, or they never intersect. Those are the 3 possibilities. And then when they intersect at 2 points, Those 2 points are just intersections. They don't have a specific snazzy name. These points that have 1 point in common, these 2 circles have a tangent. So they're called tangent circles. And the same tangent applies to both circles. This one is called an external tangent because it's on the outside of both circles. And this one that runs in between the 2 circles, that is called an internal tangent. Common internal tangent. Then we have circles that don't have any points of intersection, and 2 different things can happen. They're just totally don't intersect, nothing special about them. And then if there's something special that they share a common center point, those are called concentric circles. So I can have a bunch of concentric circles like on a bullseye, and they don't have any points in common. They never intersect at all. They don't have any tangents in common. They can't because they don't meet. So make sure you have these guys down. So if we want to find common tangents, and we have these 3 different possibilities, no intersections, 1 intersection, and 2 intersections. And we're looking for something that is a tangent to both circles. When the 2 circles never meet but are not concentric, one's not inside the other, we will have some tangents that are external. Let's see, externals are blue. So those external tangents, we're going to have one that goes kind of this way, and another one, and hopefully I'll catch it. This guy should have moved down a little bit. So those are external tangents, so they're in blue. I can also have external tangents on 2 that are intersecting. Notice how they're going to tend to touch both circles, but not go through the center of them at all. Then the way that we have an internal tangent, that is when they are in common. Just try to get through here. So we just want to make it go through the center part so that it touches each circle 1 point. Those are internal tangents. Now, when we have concentric circles, they are going to have no tangents that are in common. They actually don't have to be concentric, but if one is completely inside the other one but not touching, there's no way that they can have a common tangent. And this will have an external, actually both of these will all have external tangents. So this, because it touches both of them, it works. All of these guys are going to be examples of external tangents. Notice we have one on each side. Touches at 1 point, touches at 1 point. So we have the point of tangency on each circle, and this will have a shared point of tangency and no tangents. So there's a couple things that happen when we have tangents. Tangents are kind of neat. When we have a tangent to a circle, it has to meet at a 90-degree angle. So guaranteed 90-degree angle right here. Always, for every tangent. The second thing that we have is if we have the tangents going to the same point. So S is on both tangent lines, and these are both tangent lines. These 2 segments are equal. So we have equal line here, Every single tangent is going to have a 90-degree angle, so that's going to give us a lot of clues that we can use to find some missing parts. So if we start out and we just want to say, well, how do we know if this is a tangent or not? And what we're looking for in this particular case is this a right angle? Because if it is a right angle, it is a tangent. So we're back to Pythagorean theorem. 12 squared plus 35 squared. If it equals 37 squared, it is a right angle, and if it does not equal, then it is not a right angle. So we have 1, 3, 6, 9 over here, and 37 squared is 1369. So I don't have to keep going, take the squares, anything like that. I can just number crunch the left and right hand side, and then I can say ST is tangent. To little baby circle P. Okay, all you're looking for is using the Pythagorean theorem, because you know that if it is a right triangle, then it is a tangent. Now, this is the trickier one to do. So we are now going to figure out the radius in order to make this tangent. So I have to use the Pythagorean theorem. This side over here is going to be 50 plus r. Yeah, I'm going to do r plus 50. Okay, so if I know that, I'm going to set this up with one of the legs squared plus the radius squared, that's the other leg, equals r plus 50 squared. Okay, so I'm going to simplify what I can. 80 squared is going to be 6,400. Got to keep the r squared. And you need to remember FOIL. Firsts, outsides, insides, lasts. So if you struggle to remember this, you're going to write it out as two of the same things that you are multiplying. And then we're going to multiply firsts. That gives me r squared. Outsides gives me 50 squared. 50r. Insides gives me 50r. And lasts gives me 2,500. Merlin, will you stop? So now, what do we do when we're trying to solve a r squared? You guys don't have a lot of experience with this, but something really nice is going to happen. When we subtract r squared from one side to move it to the other, it is going to cancel on both sides. 6,400. So we have 100r because these two combine, and 2,500. So we're going to subtract 2,500. So that is going to give me 3,900 equals 100r, and dividing by 100. So it's a little tricky to set up. You do have to remember to FOIL, first, outsides, insides, lasts. But once you do that, you can find the radius without actually having to solve a quadratic yet. So just make sure that you're doing the hypotenuse as the radius plus the part that's on the outside. Here's another type of problem. This is two lines that are tangents to the same circle that go to the same point. These two things must be congruent. God, you guys are obnoxious today. So my equation becomes 28 equals 3x plus 4. That's easily solvable. So we're going to move the 4, ending up with 24, dividing by 3, and x has to be 8 in order for these two things to both be tangents to the same point. Useful little tidbits of information. Are we tangent? Well, the radius has to be the same everywhere in a circle, doesn't it? So this side is 5, n is 3 squared plus 4 squared equal to 5 squared. And yes, this is 9 plus 16 is 25. So since both sides are equal, then this is tangent. Okay, we have another one to set up. That's the hard one. So remembering that this side is going to be r plus 18, our equation is r squared plus 24 squared. That's doable. And this is the part that we're going to have to FOIL. So remembering that FOIL is write them both out. So 24 squared is going to be 576. Firsts, outsides, insides, and lasts. 18 squared is 324. Then we combine like terms. So if we move this r squared right away, we're going to get it down to 36r plus 324. Then we're going to subtract 324 from both sides. Giving me 250. 2 divided by 36. And we get a radius of 7. Okay. So the setup is a little bit tricky. They do simplify nicely because of the r squareds canceling on both sides. Anytime we have points of tangency, the two sides are congruent. How do we get rid of the squaring? The undoing of squaring is take the square root. Since lengths must be positive, x has to be 3. Now, because x squared is the full length of the side, we could actually have x equal to negative 3. If we saw it as any part by itself, I would have to stick with positive 3. So if it was on the radius, we would. Okay, your homework is in Google Classroom, and we'll probably have a Google Meet on Wednesday. Have a good day.